Welcome back, my mathematically minded minions and minionettes. Well, we're getting to a point where it's time to start wrapping up this first half of this unit on quadratics. So we're going to re-look at the forms of a quadratic function and some of its key features. So we're going to examine these things. We're going to take a look at them, see if we can recognize what form they're in, what are some important parts about this, and then mention a couple of key features about these graphs. So let's look at our first one. So we've got f of x equals 2x squared minus 3x plus 12. Okay, so when we look at this one, first of all, we need to look at it and see, is it in a form? Is it in one of the forms that we've looked at? So you got to remember what the forms that we've examined up to this point. We've looked at standard form, we've looked at intercept form, and we've looked at, and another name for intercept form, of course, is factored form. So we've looked at standard form, we've looked at factored or intercept form, and then of course we've looked at vertex form. So it should be in one of these forms, and this one. So obviously if we look at it, it is in standard form right now. So standard form, and if you remember, standard form is the one that is ax squared plus bx plus c equals 0, or equals f of x, or equals y. So then the question is, well, what does standard form tell us? So we've got to remember that the A tells us whether or not this thing is it smiling or is it frowning? Is it looking up or is it looking down? Well, obviously that 2 up there, it is positive. It is positive. So a positive one, we said, hey, positive people like to smile a lot. So it's smiling. It opens up. It opens up. Well, the next question is this thing narrow or is it wide? Well, that 2 there, from looking at that A, we said this first one, that's from looking at the A there. Well, we can also look at the A there, and we know that if the A is between 0, it's between 0 and 1, which this one's not, that would make it wider. And if the A is greater than 1, which is what we've got right here, if it's greater than 1, then this thing is narrow, it's skinny. So we're looking at a narrow one that's been stretched vertically, one that's been compressed horizontally, so we can look at it. Well, the last thing that we can look at when we look at a standard form equation is the y-intercept. And we look at the c to tell what the y-intercept is. And that y-intercept, in this case, is 12. The y-intercept is 12. So from the standard form equation, we can look at it, we can see that it opens up, that it is smiling, it is positive, so it's opening up. The A is greater than 1, so that A up there is a 2. We can see that. So that means that it's narrow, that it's been compressed horizontally, it's been stretched vertically. And we can finally see that the y-intercept is 12. So hopefully you got that. Let's look on to the next one. All right, so look at this one. You may want to pause me right now and take a look at this one, decide what form it's in, and or if it's in a form, and then go from there. All right, well, close inspection, when you start to look at this one, the first thing we see is, hey, this thing is in intercept form, okay? It's in intercept. It's in intercept or factored form. So we look at intercept or factored form, and we know that intercept form should look like A times x minus p times x minus q equals 0, or equals y, or equals f of x. And we look at this one. But hey, there's something a little weird about this one. Notice this first one right here. Hey, we got this negative 3x minus 12 in there. Well, normally we don't have a negative inside our factor form, do we? So, because if there was, so hey, this thing isn't done. Somebody forgot to factor everything out. So notice, anytime you wind up with a negative up there, or always look at these things and double check. Notice we got a 3 and a 12. Hey, both of these, 3 can come out of these. So somebody forgot to finish factoring this. So let's go ahead and do this. It should be negative 3 times x plus 4 times x minus 2. So somebody forgot to factor out that negative 3 out of there. And hey, if we hadn't caught that, that would definitely change some things going on right here. So we see it's in intercept form or factored form. And we know that factored form leads us into a couple of things. But let's go with the first question. So now from this one, is this thing smiling or is it going to frown? Well, if we'd have looked at it at the beginning, before, if we hadn't caught that -3 in there, if we hadn't factored out, we would have said, hey, there's a 1 sitting out front of that, so it's got to be positive, but it's not. It's got a -3 as the A. So this thing is frowning. It is opens down, okay? And realize we look at the A for that. So it opens down. It's negative. We can also look at that A, and we could tell, hey, because that A is a 3 or a -3 in this case, that means that this thing is going to be narrow. It's going to be a skinny looking graph. It's been compressed horizontally. It's been squeezed in. So this one's skinnier than what our normal one is. All right, now we get into factored intercept form. What does that tell us? Well, we look at this. We can look at those P's and Q's. We can look at P and we can look at Q, and they tell us what the roots are. So the roots, or the zeros, or the x-intercepts, in this case, the roots are at -4 and +2. Or we could say the x-intercepts are at -4, 0 and +2, 0. Remember, anything in parentheses, it's always going to be the opposite of that one. So we could write it either way. They both mean the same thing. The roots are at -4 and 2. Or we can say they're at negative, the precise point coordinate is -4, 0 and 2, 0. Those are where our zeros are, our x-intercepts. So there's our second one. All right. So let's go to our third one now. So, well, we saw after that second one's a little tricky. We better pay close attention here. This one here. Well, it kind of looks like a form we've seen before. We see this, we got this quantity squared up there. It's got this number, but it's out in the front. So it kind of looks like vertex form, right? I'm kind of thinking it resembles vertex form. But vertex form should be A times x minus h squared plus k equals 0 or equals y or equals f of x. But this one here, we got this -5 at the beginning. It's at the wrong place. Can we move that to the end? Absolutely. So let's go ahead and move this thing to the end. So let's rewrite this. Go ahead and squeeze it out over here. Y equals, so now we don't need this positive thing anymore. So what do we got? We got -x minus 3 squared. And we're going to move this -5 out here to the very end. So -5. Okay, hey, that looks better. Looks good, looks good. Oh! Anybody catch that? Trying to be tricky now. I got this negative out in front. We shouldn't have a negative inside of here. It should be positive in there. So we need to get that negative out. Somebody forgot to factor out. Again, people getting sloppy. So this time, because we've only got one x and a 3, the only number it factors into 1 and 3 is 1. So let's factor out a -1. That leaves us with x plus 3 squared minus 5. All right, so now we're good. Now let's look at the A. Is this happy or is it sad? Is it smiling? Is it frowning? Is it opening up or opening down? And the answer is it opens down. Why? Because that A is a negative. That leading coefficient, that number out front, that -1, it's negative, so it opens down. The graph of this is going down. We can also look at that A and see, hey, it's a 1. So is it wider? No. Is it narrower? No. This right here just happens to be, it looks like our parent function, okay? So it looks like its parent. It looks like the parent function. It's neither wider nor narrower. It hasn't moved anywhere. It is exactly 1. So it's no wider, it's no narrower. It's just like the parent function. It's just opening down. Well, the last thing when we look at, or well, next to last thing, when we look at the vertex in vertex form is we can find the vertex. Well, how do we find that? We use the H and the K. Where's H? H is inside of the parentheses. So inside the parentheses, it's not really a 3, is it? So the vertex is, it's always the opposite of that. So the vertex is -3. Where's this K? Well, K is outside. So we just leave it alone, take it as it is. So the vertex is at -3, -5. So there's our vertex. Now, when we look at the last thing they asked for is the axis of symmetry. Axis of symmetry. So if we look at this, well, we know it is a vertical line. We know it's a line going up and down. And we know that every vertical line has an x equals equation. So we know it's x equals. Well, it's x equals what? Well, the axis of symmetry happens to be the h value. The h value, which is in our vertex. It's right here. It's -3. So this is x equals -3. So there is our axis of symmetry. It's our h in this case. Now, remember, if we had left it in standard form, if we'd been in standard form, we could have found the axis of symmetry as well there, -b over 2a. I would encourage you, if you don't already have that one memorized, along with these forms, I would get it memorized. You will need to know it before the test. So, just wraps up our little review here of the different forms and what it shows. Hopefully this helps you out, and I will see you back in class.